So hey guys, welcome to this new video. And I'm pretty sure from the thumbnails and from the title itself you might have guessed what is the today's topic. And yes, the topic is a vital topic. So obviously we will be going to see here about MSD, which is musculoskeletal disorders, which means any kind of injury in near future to the ligament, joints, bones of your worker or your workforce, especially when they are working in manufacturing units or in factories, or like in warehouse where they have to do sort of manual lifting. So literally you should know, like as health and safety coordinator, like how much lift your manpower is lifting, what about their RWA relative workload, what about the load index. All these factors must be known to you, right? uh, I must say these factors are, or this topic is very important for people who are preparing for higher examinations in health and safety, and also if you are looking for jobs in the Western Front, like in Europe, in Canada, US, because there, unlike Gulf and in India, they give more importance to the health and safety of the workers. So you will be sued, or you will be fined, you will be responsible for the health issues of the workers at the site. And probably there may be chances also that insurance companies won't uh, give you the settlement also if there is injuries related to MSD in this kind of country. So you have to be very informative. You have to be very dedicated to your work in health and safety in such countries. Because you are working as a health and safety advisor, so you have to advise on all the aspects of health and safety in a firm. So let us start our discussion. You can guys see a image where a worker is doing his regular manual lifting work. He is lifting a medium-sized load from the bottom of the station, okay, platform, and he lifted it. He is carrying it in the second figure, and the third he is placing it on the top of the table. So in one way it looks fine, but just imagine if he does it all the day, 10-20 times in a day. So what will be his condition at the end of the day? So is he safe? What are the chances of getting MSD in near future for this worker? And this is the case of one worker, but just imagine a big warehouse or a factory where lots of workers are working. So guys, now listen it carefully. You can see I have made a schematic diagram for you. So this guy, just imagine this is the guy which we have seen in the previous figure, and he's doing this activity. Okay, so here you have to find out the lifting index for this person, for this particular activity. So obviously there arises a question, what is lifting index, right? So lifting index is, friends, the ratio of the total load, proposed load, divided by RWL, which is recommended weight load for this particular task. So RWL is like a appropriate, or we can say the proper weight which can be adjusted from our side. Okay, so how it can be adjusted, we will see. There are some factors which need to be adjusted. So suppose if lifting index is less than 1, it means very good, the ratio. If the lifting index is equal to 1, it is normal, the average. And if the lifting index is greater than 1, then obviously you have to make sure that you do or take some necessary steps. So okay guys, focus on this image on the top. So you can see there are 6 factors which can cause MSD, musculoskeletal disorder. So the first important factors, the one is the horizontal distance from the load. So you can see the center of the 2 legs at H on the left side. You can see that is the distance of your legs from the load. Okay, now we will see what is the second. The second one is the V, which is box lifted and kept at V. that is height equal to V. So what is V? V means the box. You remember the first image in which one person was lifting it from the down, then he kept it on the top. So here the V is the distance which he has lifted the box from the ground to his hand, okay, before he completed placing the box on the top of the table. Now D is the height of the lift, like from that position where the V ends, how much he has lifted and where he had kept. Okay, so D plus V will be the total height which was lifted by this person. Well, don't worry, we will see all this with the example. Now the fourth factor, it will be the angular factor. So it is like how much angle the wrist moves while placing and taking the objects, right? So that is what angular multiplier. Sorry, I forgot to mention this M in all the parameters is multiplier, okay, which we will see in the equation. Now the fifth one is the frequency multiplier, which is like how many times they are lifting, they are placing the object, right? And finally the sixth one, which is coupling, like the total quality or the grip of the workers on that particular object. So that is what comes in called coupling multiplier. So guys, here's the formula for calculating recommended weight load, which is LC. LC is the load constant, which is the appropriate or the maximum load which can be lifted, which is around 23 kilogram, and in pound it will be around 51 lb. So always make sure that wherever you work, you have to take the units accordingly. If the units are in kilogram, then go for 23. If the units are in pound, then go for 51. Okay, so this is the formula: the load constant multiplied by HM, the horizontal multiplier, vertical multiplier, distance multiplier, and the angular multiplier, the frequency multiplier, and the coupler multiplier. So guys, the first four multipliers, it can be obtained from the site, from the scenario, but the remaining two you have to get it from the chart or from the table which will be shared with you. Okay, so guys, this is not the final formula. The final formula will be something else. This is like the principle, like you have to multiply everything, but when the real formula, when you see, it will be vary, and the real formula is shown in the next slide. Okay, so guys, as I said, this is the real formula on the down, which obviously is not easy for you to remember, but for the exams it will be given to you, and it is also available on the websites, different websites, so you can, there is no need to remember it. Okay, even for your professional exams this formula will be given to you. So let us see how we can calculate. So like, assume assembly line is 20 inches above the floor. So here we got the V, right? V will be 20 inches. Now places them in a box which are located 35 inches above the floor. So 35 inches is the total height, and out of that, if V is 20, how much will be D? It will be 35 minus 20, so 15. Now the weight of each product is given 15 lbs, right? For each lift, the distance of hands away from the midpoint between ankles is 12 inches. So we got the H, right, which is 12 inches. The next, the worker needs to turn 45 degrees. So it will be your angular multiplier. The worker places 5 finished products in the boxes every minute. Okay. The coupling type is classified as good, and the relative, the recommended workload for 3 hours of continuous work is question mark. You have to calculate the recommended workload for 3 hours of this duration. So as I said, the coupling and the frequency multiplier we will be calculating from the table. So we will see how. So there are two formulas, like if you are using all the factors in kilogram, then go for the first one. If you are using in pound, then go for the second. So you have to change the parameters also accordingly. So basically for the kilogram, all the units like HVD will be in centimeter. For pound, it will be in inches. So guys, literally all the parameters which we discussed is available to you except coupling and frequency. So for coupling, what you have to do is you have to refer this table where you can see it's already mentioned coupling type as good, right? So the coupling, what will be the coupling multiplier for the V, which is less than 30 inches here? So yes, you got it, it will be 1. So for the coupling type good, For vertical distance less than 30 inches or 75 centimeter, it will be the 1. So the coupling multiplier for this particular situation will be 1. Now let us see the frequency multiplier. Okay, for frequency multiplier it was given 5 lifts per minute. So how much was the duration? The total work duration was for more than 3 hours, right? So we will going for this tabular column in which you will see less than 1 hour, greater than 1 hour but less than 2 hours, or greater than 2 hours but less than 8. So we will go for that option, right? Where V is also less than 30. So it will be 35. So the factor will be 35, and you have to put all these factors into that formula, and you have to go and check the RWL. So here's the formula again. So you can write it down on the piece of paper. So these are the formula, these are the values which you have to insert, and you will get the recommended weight load in kilogram. And after that, don't forget to put that RWL where? Yes, of course, in this formula for finding out the lifting index, where it will be the load divided by RWL. And as I already said, if the lifting index value is less than 1, it is very good, and other factors you can consider. So I hope this is clear to you. It will be very useful for your exam, and I will like to share one scenario for you where you can work out, and you can write down to me in the comment section what is the value which you got. Okay, so here's the scenario. So guys, it is clearly mentioned on the screen. All the values are also given. Try to find out from your side. All the informations are given in the video. Watch it again if you don't remember, if you don't understand, and ask me any queries if you have. So see you soon. Another blasting video.